Hello, viewers. Welcome. Let's have the continuation on our episode on permutation and combination. Just ended episode, we deal with episode 17 of the permutation tutorials, and in this episode, we are beginning another episode on combination. So this become the first episode on combination, but in a larger scale, the 18th episode of the topic permutation and what combination. What then is combination? It is just a selection of items from a larger set where the order of the item does not matter. Remember, under permutation, we say it is arrangement of objects where the order of arrangement is very what important. All right. Then, what are some of the real world applications that we can deal with when it comes to combination? It is used variably in what? Trigonometry, probability, and calculus, but as application, it is normally used in counting the number of ways to select a team from a group of four people. If you have a group of people, you want to select a particular team or number of people from that pool of people, we are going to rely on what? Combination. People also apply it largely in what? Lottery, where we can be able to look at how many combinations we can get from 0 to 9 if we are picking a single number. These are all applications of what? Permutation. Now, to begin with, we are going to start it with permutation based on the information here that says that where the order of item does not what matter. How do we apply or explain that particular statement here? Let's take, for example, if we have A, B, C, which are three letters which we want to arrange. In this arrangement, we are picking what? All the three at a time. So what are the various arrangements that we can get from here? We can see this number itself, which is, letter itself, A, B, C, could be one of the arrangements, whereby I can also get A, I can get what? C and B. A, B, C. So I'm picking A, C, B. I can also pick B, C, A. B first, C, and A. Or we can begin with B first, A second, and C. How about C beginning it? When C begin, I can come back to A and what? B. Or C is beginning and I am coming back to B and A. These are the various arrangements that we can get. So we are having 1, 2, 3, 4, 5, 6, which explain the permutation. For 3 permutation, what? 3. Meaning I have 3 different letters which I am picking 3 at a time. We explain that to be 3 combination, 3 minus 3 or combination, which we are aware it will be 3 factorial, which is 3 times 2 times 1. That is what? 6 ways from the permutation calculation we did. So this arrangement, let's just call this one permutation. Okay. Then let's think of combination. What are we doing? We are going to combine. We have 3 different letters. Remember, selection of item from a larger group. What is a larger group? We have 3 different letters we want to select from. Now, then our selection is going to be 3 of them. We want to select 3 letters from 3 different letters. 3 letters at a time. So what am I going to have? I'm going to have A, B, C. Now, if I select A first, I have a chance of selecting B second and C. That is the combination that I can have. Now, if I select, let's say B first, and I come to select C before I select A, at the end of it all, how many letters am I having? I'm still having A, B, C. So this combination here is just having only one combination. only one combination. The difference between these two is that this is being done when we are dealing with password. For example, your password could be BAC, that's back. Then I can decide to have my password to be CAB. CAB. If my password is cap and yours is back, if you use mine in place of yours, it will not work because these two numbers words are different. Do you get it? This is different from this. So you mean the arrangement, the order of the arrangement is very important. The importance of the arrangement is important. When it comes to here, we are not interested in the order of the arrangement. So I'm having A first, B first, second, and C. At the end of it all, I am having A, B, C. If I went and pick C first, pick B, and pick A, at the end of it all, how many combination of the three letters am I having? I still have the A, B, C. So this is the only one combination we can get. Do we get it? Now, if you look at it, if it is only one combination we have, then what is the difference between 1 and 6? You can see that if I divide this 6 by itself, I should be having what we call 1, because this is 1. So if I want to deal with combination formula, combination is C. Let's leave it like this first. It will be equals to the permutation that I have, 3 permutation what? 3 divided by what? 6. This is the 6. If I divide the permutation I have 6 ways by 6, I should be arriving at 1, which is the combination that I have. Do we get it? So that's one combination. Now, this 6 can also be written as 3 times 2 times 1. 3, 2, 1, or multiply, give me 6, which is referring to what? The 3 factorial. So this could also be 3 permutation 3 divided by what? 3 factorial. This factorial is referring to the number of items I am picking from the pool, from the larger set. Do we get that? So if that is the case, how do we expand this? Remember, this is going to be 3 factorial on 3 minus 3, as we are seeing it that way. Now, how about we are saying that combination by definition is I have n different objects I want to combine, then picking R at a time. This is n combination R or n choose R. That simply means that I am going to deal with n different of objects, which I am selecting 3 at a time, divided by what? The R factorial. Remember, I mentioned that the 3 factorial, which is the 6, is referring to the number of items I am selecting at a time, not the larger set of numbers available to me. So this can be given in that direction, whereby we can expand the permutation as n factorial divided by n minus r all factorial. That is what we have. Remember, a over b divided by c, the same as a over bc. If you can remember this, we are picking this as division. So a over b divided by c. A over b, this becomes multiplication, reciprocate. 1 times a, b times c, bc. So this is a fraction on its own. The permutation is a fraction on its own, divided by another term. So this term, which is the c, from here, the r, will now go and multiply the denominator here. So that will become equals to r what? Factorial. I believe you've gotten the concept. So permutation is larger compared to combination. So a combination is going to be n combination r will be given as what? N factorial divided by r factorial times n minus r all factorial. So that gives us our final expression of what? Combination. I believe I mentioned that this is n combination what? R. Okay, so let's make it a small note. We can pick the first one to be n combination R, the same as n combination R. which is also the same as NR, also the same as C, N, and R. This is given to us by N factorial, R factorial, N minus R what? Factorial. This is what? By definition. So by definition, if I am dealing with combination, all that I am interested in is going to be N factorial divided by R factorial times N minus R all factorial. This is the definition. But it is not always that we are going to apply this. So let's deal with the practical way of application of this when we are faced with what? A question. So right from here, we can have our second note as NR. Don't forget, I am referring to the same thing. Which is the same as this. You can see them in written form 1, 2, 3, 4. By most of the calculation, I'll be dealing with this. I'm using this because of space. So this will be equals to N minus 1, N minus 2 up to N minus R plus what? 1 divided by R factorial. I think in one of the episodes, someone asked what the R stand in for, which is the number of items you are selecting at a time. The N referred to the larger set of objects you are to choose from. Alright, so this is what you are going to be doing. So we can say that this one is in practice. I'll be dealing with this as in practice. So for example, let's say, I have 6 combination 3. Like this. 6 combination 3, as in the case of this. What is it going to be by definition? By definition, it should be 6 factorial over 3 factorial, right? 6 minus 3 factorial, which in larger sense becomes 6 times 5, 4, 3 factorial on 3, 2, 1, 3 factorial. 6 minus 3 will give me what? 3 factorial. So these factorials will cancel. This is 6. So I'll still be having only what? 5. Meaning there are 5 ways by which I can select 3 objects from what? 6 objects. So let's just say ways. This is by definition. How about by practical? So by practical way, what are we saying? We are saying that you have 6 combination 3. Yours is to just have the 6 times 6 minus 1. That is 5. You know it? Minus 2. That will be 3. Up to this number. What is this number? N minus R. Meaning 6 minus 3. And 6 minus 3 will give you what? 3 plus 1, 4. So this is 4 divided by 3 factorial, which is 3 times 2 times what? 1. That is the practical application. If you don't want to do the expansion by definition, we can do the application in this form. We just give us, if I have 3 here, I have 3 expansion. If I have 4 here, I have 4 expansion. And that will still give you these 2 cancelling. Okay, I think the first one will also be 5, 4, 20. 20 ways, whereby this will cancel 6 and still have 4, 20. So by definition, we can expand. There is no problem. If you have time to expand, you can expand. Then by practical way, we can also deal with this expansion just by picking this as the denominator, then expanding the n times according to the number of terms I have here. So if 2 is here, last in 2 is here, I only expand it 6 and what? 5. That is the aspect we are having. Alright, so let's see. Number 3, we can also say that if I have n combination R, let me just say the R is 0. It gives me 1. What does it mean? That means, so the explanation we can give is that there are only one way of choosing no object. We are not choosing any object out of what? N object. So if I have 5 objects, then I say I'm not choosing anything. There's only one way that I'm not choosing anything. So if we have n combination, so this is also the same as n combination 0, which is the explanation here. You get what? 1. Or if you have it to be n combination 0, it is still going to be what? 1. Then number 3, we have n combination n, will also give you 1. That is, so by its definition, there are only one way of choosing n object out of n object, which can be seen from the very beginning when we have A, B, C, which is 3 letters. You want to choose 3 at a time. How many combinations do we get? We get only one combination. So if I have 5 combination 5, the answer will be 1. 10 combination what? 10, I'll get 1. Then the final one could be, if I have n combination r, that should be the same as n combination n minus r. This is the same as this. If we have what? R greater than or equals to, let's say, n on 2. Better still, we can say where r is what? Larger. When the r become very big, that is, but not bigger than the n anyway. When it is large, closer to that of the n, it is good to use this very combination than using this, because working with this you are going to be working with a larger pool of numbers than when you are to work with this. So this is just when we have n divided by this. This is bigger than that. Let me just say bigger, if not equals to. So this is what we are going to be dealing with. If this is 6, 4, we can say 4 is bigger than 6 by 1 in terms of half. So we can apply this one. Now let's see. Supposing we are having 13 players and we want to select only 11 players to play. So 13 objects, selecting 11 at a time. Now going back into the definition of combination, meaning we have n combination what? 11. What would that mean? By definition, I'm going to say 13 combination 11, which means 13 times 12 times 11. Let's just say we are going to have it as 13 factorial on 11 factorial, 13 minus 11 all factorial. You can see in the case of this, we should be having 13, 12, 11, let me just say 10, or let me end it here, 11 factorial. Then I have 11 factorial times here, it will be 2 factorial, right? If we check this 11 factorial, we cancel this 11 factorial, then you should be left with what? 2 factorial, which is 2 times 1. And that 2 go here 6. 6 will multiply this as 60, 70, what? 8. That is by definition, if you are to expand it. But if you want to pick this, which says that 13 combination 11 is the same as 13. 11 from here will be 2, which will give us the, I think in the second note, we can say that this become 13 times 12 divided by 2 times 1. I guess from the I think this is third, so this will have been fourth. From the second note that we have the expansion to be n minus r plus 1. So 13 minus 2 plus 1, this will be 11 plus 1, 12. So 12 is going to be here. So if I have 2 here, I expand 2 times. And you can agree with me that if you expand this will go here 2 times, that will still give us what? 77 what? Ways of what? Selecting those 11 players to play. Now, this aspect is also saying that if I have 11 players to select, It also means that there are two players that will not be playing at a time. All the time there will be two players that will not play. So that two players is what you are seeing in here being displayed here. If I am selecting R, what is the remainder? The remainder in terms of the choice will also be the same as if I am dealing with the selection I'm doing at the first time. So that is what is happening. I am selecting 11 players. It's the same as if I am not selecting 2 players, because 2 will be left when 11 are gone to the pitch. So I will deal with those 2 selected. Then will also tell me the combination of 13 people when 2 is not selected to play. So with this 4 notes that we have, I think 4, so this will be 5. I think my arithmetic is getting problematic. All right. Now, looking at all that we have done so far, you can attest that combination is a little in value than permutation when the same statement is placed. So it is now relied on us to be able to identify whether permutation or combination is required of us in a particular question. Most of the time, there are only 2 ways we can identify that. One, when there is a word selection of object. Selection is dealing with what? Combination. When there is a word arrangement, the arrangement dealing with what? Permutation. Or when you can be able to understand the wording of the question to tell whether the order of arrangement or selection is important. When the order is important, then you are dealing with what? A permutation. When the order is not important, then you are dealing with what? Combination. I believe this tutorial introduction will give your interest on what the next episode is going to be. Next episode is going to be dealing with questions that we can be able to apply the principles that we have learned in this tutorial. I will indulge you to share this video with somebody who may need this tutorial, who may also benefit from it. Subscribe to the channel if you have not. Share, comment, and like.